Thanks, Andrew, and thanks everybody for staying with us. We're going to switch over to the dark side now a little bit. Been speaking a lot about concrete and concrete pavements. It's my pleasure today to give you an update on implementation of a binder specification that I've been working on with Jerry and Darren Hazlett for almost my entire career, so about 15 years. And we're pretty excited that we're actually implementing it and gaining some interest in the use of this specification. And I'll talk to you about what that is. So basically the whole idea was started with Darren Hazlett thinking, I'm going to try to summarize this. Basically when TxDOT switched over to a PG specification for hot mix binders, that basically we're hopefully going to have better performance. We're going to have less variability, and we're going to tie directly to the climate. We're going to look at the properties that are important to the performance over a wider range of temperatures, and we're going to look at critical aging conditions. And so the same thing basically is applied here. Let's take the older traditional way of specifying chip seal or seal coat binders and sort of have the same benefits by creating something we call the Surface Performance Grading Spec, or SPG, where we're going to use performance-related tests, again, temperatures that cover the entire spectrum, critical aging conditions during the first year, based on talking with TxDOT personnel, that generally if the seal coat or chip seal lasts that first year, then it's generally going to last its intended design life, and try to tie directly to the climate and possibly also include the effects of traffic. So right now we're in the third year of a 4-year implementation effort where we've sort of stepped along the way. Right now we have quite a few sections in the Corpus Christi district. Next year we'll have many more districts participating. The idea is that we've come up with a specification for the in-service properties of either a hot applied binder used in a seal coat or the emulsion residue of the material sprayed down for the seal coat. Really quickly, there's been about 15 years of research done on this, and at more than $1 million spent. We've really been the leaders here in Texas. There's a lot of interest in this effort nationally because we've actually tied to field sections, and nobody else is really doing that. I was also involved as a subcontractor on an NCHRP project. However, I'm not involved in the current NCHRP project directed at this same topic. We went through a lot of looking at different emulsion residue procedures. We've tried a lot of different tests as they've come available for hot mix binders to try them and see if they could tell us anything. And we've tried to basically adjust what's in the PG spec, use the tools that we have at hand, and develop something that's applicable for chip seal or seal coat binders. I want to emphasize that this is a part of a system. It's not telling you everything. It doesn't include the emulsion properties as they go down. It's for the material as it's used, its performance properties in service. I know you can't read all this. The idea of this slide is just to show you that it's the same framework as the PG specification. In other words, you have a high temperature and a low temperature, and I'm going to step through this where you can actually read the parts, but I just want us to show you that we use the same tools. We use the DSR, we use the BBR, we have different aging conditions. We have an unaged or original binder, and we have PAV aging. We don't have any rolling thin film aging, as these binders are not going through a hot mix plant, so that is not applicable, we felt. And so I'm going to step through this step by step, but it basically has the same framework. Right now in the SPG spec that's currently revised and approved as of August of this year, we have 15 SPG grades, and you'll notice that they're by 3° C increments. And you say 15 and 3° increments, that might lead to a lot of different grades. But currently Texas has 18 PG grades at 6° increments, so we don't feel that it's excessive. This is just blowing up, looking at that table that we just saw. So I want to mention that we're using the SHTO PP72 method B if it's an emulsion to get the residue. And this was also originally developed here in TxDOT. We called it the warm oven method, where you're just getting a very thin layer on a silicone mat in an oven. For 6 hours at 60 C. We looked at making sure we got all the water out. We looked at lots of different things when we were looking at the different emulsion residue properties. If it's a hot applied binder, there is a flash point and a rotational viscometer criteria that was from the original research project. The other thing to note on this slide is that it's surface pavement temperatures, which is the same for the low temperature end as for PG. But for the high temperature, if you remember in PG, it's at a 20 millimeter depth. So this is a surface pavement temperature because that's what's applicable for seal coats. On the original binder, we're using the DSR, and we have a G star over sine delta, same parameter that we would for PG, but we have a different threshold. We have a threshold of greater than or equal to 0.65 kilopascals. That threshold was set based on the 75 field validation sections to date. Prior to the start of the implementation project, which is in 2013. We also had an intermediate temperature property that has since been removed in the most recent look at the specification. Basically, it was originally based on just about 6 field projects from the NCHRP work, but we, in subsequent use on many field sections in Texas, we don't feel that it adds to our delineation between good and bad field performance. At the low temperature end, again, only through the PAV, we have limited data, but we think that the PAV does get you to that first year, 1 or 2 years of aging, and so we think that is the critical state. We have the S value less than or equal to 500 megapascals, and one other thing to note that's different than the PG spec is that it's at an 8-second loading time, and we are testing at the cold temperature. So there's no 10-degree time temperature shift. We're not trying to look at long times of loading with low temperature cracking like we are in hot mix. We're looking at 8 seconds because that's the fastest in the BBR that we could get repeatable data. Of course, it would be nice to be even faster, but for those reasons, we're looking at 8 seconds in the BBR and actual cold temperatures. Again, we had an intermediate temperature property at 25C that has since been removed because it wasn't adding to what we were doing, and it was causing a lot of confusion as we tried to implement this. We have done quite a bit of technical briefings with TxDOT and industry. We formed a task force with AGC. We've met at TxAPA and had briefings. We've done presentations at SHTO. We've done publications and reports. Papers at TRB, presentations at TRB. We've met with industry on request a number of times, and it's really been a collaborative effort with us and TxDOT, and we appreciate that. So the idea is that we would determine the SPG requirements initially based on climate, and then make some adjustments based on traffic or other considerations, including whether you were interested in having a polymer modified binder. This is the sort of baseline environmental requirements in Texas. This, you'll see, it goes from a 67 minus 13, and then it kind of goes diagonally up to the panhandle. It's 67 pretty much for the majority of the state until we're way up here, and then it's a 64. And then it just steps across by 3-degree increments. Minus 13, minus 16 in yellow, minus 19 in green, minus 22 in blue, minus 25. So it steps across in a diagonal manner with the changing climates. And again, this is sort of the lowest level SPG grade that we would want to put on maybe a very low traffic volume facility. Jerry's going to talk a little bit more on how he's been helping the districts that are going to participate next year select which SPG grade they would want to utilize. So in the implementation project so far, we have used that spec that I just showed you to look at 29 binders in an additional 19 field sections from 2013, monitored their performance at 1 year in 2014, and monitored a few more of their performance at 2 years in 2015. Then the 2014 sections, we did 16 binders from 24 field sections, and then we just looked at those at 1 year in 2015. So we're continuing to make sure that we feel comfortable with the thresholds that are in the SPG specification. So in addition to the 75 that were used to develop it, here we have another 25, I don't know, whatever that is, 45 about sections. In 2015, we had the Corpus district that is using it on a pretty widespread basis. They're using an SPG 70-19, which if you look back at the map, is 1 3-degree increment higher than they would be required by the environment, basically because they're using it on higher traffic volume facilities. and they went to a -19 to get an 89 between the 70 and the -19 to get an 89 useful temperature interval, or UTI. And when we do that, the new requirement is that there's a phase angle requirement, which I'll discuss in just a minute. And so they did that partially to make sure that they were going to get a polymer modified material. Next year, we have 7 districts that are already on board listed here, with a few others that are considering it. And so our goal is to get, maybe 8 to 10 districts utilizing this next year. And that would be the final year that we would be actually doing the implementation, tracking everything, and making sure that we feel comfortable with the specification. Along the way, we have done a few additional things. Just want to touch on those a little bit. We do want to do more work in making sure that the PAV is simulating that critical first year of aging. However, the majority of the time we're using pre-coated aggregates, and so it's very difficult for us to try to get the binder off of the field section. So we haven't been completely successful at that. But we do feel like that the performance has leveled off in the majority of sections at 1 year. If they made it that 1 year, then they usually are in pretty good shape. We have thought about going to 6-degree increments, but I don't really feel the need because we don't have an excess of the number of grades. We have tried to look at traffic effects in terms of bumping up that high temperature end 1 to 2, 3 temperature, 3 degrees C grades. And we did add this phase angle requirement, that the phase angle has to be less than or equal to 80 at the continuous high temperature if that useful temperature interval is greater than or equal to 89. So this is only required for the grades where the spread in temperatures is 89 or greater. And we've seen lots of the binders that are in use today can meet that. Any of the modified binders meet that specification. And basically none of the unmodified binders. We've also tried pretty hard to try to get rid of the BBR. So right now we still have the BBR in there for low temperatures. And people don't want to do that. It takes a lot of material. It possibly messes up your polymer network that you as it would be in the field to pour the beam, to reheat the material and pour the beam. So we've been trying with lots of different methods. People have 4mm DSR ways of using frequency sweeps and predicting low temperature properties, but we have not felt comfortable with the way that gives us what the BBR gives us. We don't feel comfortable with the correlation between those predicted low temperature properties and measured low temperature properties. So for right now, we still have the BBR in there. We've also tried a number of other intermediate temperature property tests that researchers are using. The majority of those are requiring a research grade DSR, so we don't think that that's at a practical level yet. So we're still searching if something pops up that we can utilize to tie to field performance at intermediate temperatures, we would consider it. So in general, we are modifying or continuing to modify the specification based on feedback from the industry and TxDOT. And we also are trying to continually document the effort. We just turned in a second report on this recently. Just as a snapshot of looking, I don't know why that did that. As a snapshot of looking at what we've done from 2013 to 2015, the last 2 years, we revised our methodology for calculating field performance, what we call surface condition index. And from the older sections in the most recent research project, we have a pretty good lab to field correlation, 80%. From 2013, we have a pretty good correlation, and we actually started to separate it out based on bleeding at high temperatures and aggregate loss at low temperatures. We have a pretty good correlation here. This is where we decided we got to keep the BBR. And then the 2014 sections that we just looked at 1 year, we also feel pretty comfortable with the thresholds that we have. So the revised spec looks like this. It's very similar, but we've removed the 2 intermediate temperature properties, and we've added in that phase angle only when the useful temperature interval is greater than or equal to 89.